so far? Oh, I did it wrong. I did it to this computer. All right, y'all. This one I had to be on YouTube. Sorry. I'll send the link to it when I do it, but I accidentally recorded on my local computer, but it's all good. But are there any
Okay.
questions anybody has on the class so far? Anything
None,
that's giving you
no,
trouble?
none for me. I just what's the length of time we could schedule a net lab?
4 hours.
4 hours? Okay.
Max four. Yep. And then you can
Okay.
only extend if nobody has a lab after you. So like I said,
Right.
and that's that you can run into that issue. That's why when you do your reservations,
Uh-huh.
make sure you're going out past pod 10.
And you can't re-access it, right? Once, I mean, like I can't work on it and I run out of time. I can't
You
come
can
back into it.
you
Can I come
can
back
do
into it?
something like this. Now, this is something not many people use. It's actually possible. Let me
Uh-huh.
go in here and I just did. I know this is a CCNA 2 lab, but it don't matter. Same difference.
Right.
Um, you can actually I got to let it boot up, but once it boots up, I'll show you how you can do it. You must use Cisco in class as your console and enable secret passwords and B2I
Yes.
line passwords, or
Right.
put no passwords on it. One of the two. You can't put weird passwords on it.
Uh-huh.
Um, but then what you can actually do is, let's say you're getting ready to have to leave a lab for some reason. You can
Hmm.
actually go to the pod and save all devices.
Oh,
And that
okay.
will save all your configs into a folder. And you can't do it right now because it's
Hmm.
booting up. But I will save it into a folder and you can give it a name like Lab 346.
Mm.
You then can do a new reservation. And when you do the new reservation, it's not going to automatically put those in there, but you just let it finish loading and you go pod load all devices and load them from the configs in the folder that you put that last set in.
You have to be in the same pod?
No, no, you just have to be in the same type of pod.
Oh, same
So
type of pod.
if you save lab 346, you can't go do lab 489.
Oh, yeah, right, right.
Yeah, I mean, but it can be a different pod. It can be pod 19 and pod, as long as it's the same lab.
Okay. So we can repeat these if we want. So I can play with
Mhm.
this for us next time.
Oh yeah, and you can even do this too. One of the cool things, you can just go into and once it's loaded, you can
Uh-huh.
just go into global config. Like you've got your configs from when you turned it
Right,
into me,
right.
just paste them back in here.
Oh, true.
So you can either just do it. You
Then
can do
you're
like
basically
a
starting over, but
yeah, but
with the
yeah,
same
you can go back in here and
configuration.
you do load config and do it like that, or you can just copy and paste it in there.
Okay.
And either one,
Oh,
but
thanks.
both will work.
Because
Yeah.
I was thinking, I'm jacked. I would have to start all over, and
No, no,
um,
no. You got
I
all
was
kind of there's
mentally
all
I
kind of
was
neat
mentally
things.
depressed about that.
No, there's
So I
all
said,
kind of
no.
no, there's neat ways you can do stuff. And
Okay,
see here,
thanks.
like configuration files that'll show all the files for different folders. So every one of your classes that you have, you actually can go in and look and find if there'll be folders and stuff in there.
Oh,
So
okay,
yeah,
cool.
which is really neat.
Hmm.
Okay.
Thank
But
you.
any other questions? Okay. Now, when we get into one of the things I like to do with instructors is talk about the what I call the points of absolute interest, or the points that every single curriculum or semester has its main point. CCNA 1 is basic router config, IP addressing, OSI model would be my three main things that students need to get out of it. CCNA 2 is full of things. It's VLANs, inter VLAN routing, ether channel aggregation. There's a bunch of stuff in CCNA 2. CCNA 3 are access control lists,
Hmm.
OSPF, NAT. Okay, those are three of the biggest things in this entire section that you really need to get.
Hmm.
And NAT is one of the most important because all of us use NAT day in, day out.
Yep.
If it wasn't for NAT, we'd already be in a whole heap of trouble. All right. So we're going to look at the purpose of NAT. We're going to talk about different types of NAT, and I'm going to discuss it how I talk about it, which is slightly different than the curriculum. Um, and then advantages and disadvantages. We'll look at static NAT, dynamic NAT, PAT, and then we'll talk a little bit about NAT 6 to 4. We
Just
won't
a just a
configure.
point of interest. I lived pre-NAT,
Yeah, yeah,
and to convert from a private B to private B networks to uh, a network where we had started using the internal IPs, and then doing all of this like we're doing with the NAT and PAT stuff at the edges. That was quite the nightmare. I worked for
Oh yeah.
Southwestern Bell at the time, and we had acquired Pac Bell and we had acquired Ameritech, and they came to the realization that this IP stuff is here to stay. And and
That's
so
fine. Go ahead.
and so we went through this conversion process where we originally were one network was everybody but Texas, and then there was Texas, and
Yeah,
then they went
of
to everybody is everybody, and so let me tell you, this is a godsend
course. It is. And
to do it now and not later. I'm like my original computer that they put on my desk was Windows 3.1. Before that, it was workstations and dumb terminals,
oh yeah.
So,
Our school actually owned an entire public Class C range.
oh,
Um,
hey.
and our local ISP, which was the local company, came to us and asked for us to give it back to them. And I mean, we legally owned it. And I said, do not give this back. I
Oh,
told them,
heavens no.
don't do it.
They couldn't pay
Legally,
you
the
enough.
contract was written. It was ours. We did not have to give it back. If they could have sat on that and sold it for who knows how much money.
No
Uh,
kidding.
and
Furnished a new building with that.
yeah, exactly. And they didn't. They didn't listen to me. So, but it is what it is. And then that company ended up selling to an outside entity, Windstream, which is horrific.
Oh,
So
yeah, we have them here.
yeah. Um, all of this, everything, if you're at a dinner party and someone asks, hey, what's RFC 1918? Well, that's the RFC that specifies your public addresses, excuse me, private addresses. So they are the 10.0.0/8, 172.16 to 131, 172.31, and then all of the 192.168. So these are our private address ranges. And there is another that, for all practical purposes, is a private range that we can talk about, and that is 169.254. It is not a private range by RFC 1918, but this is a PIPA, automatic private IP addressing, um, automatic private IP addressing, a PIPA. So this is from Microsoft, and it came out around Windows 95 for a DHCP enabled machine that cannot find a DHCP server. It will automatically assign itself an address in the 169.254.x.x range. That is not an RFC 1918 address, but I mention that here because a lot of times you'll see that, and students need to know that's automatic private IP addressing. Okay. So what NAT does, for all practical purposes, is translates from a private to a public address. So every ISP in the world has access control lists. Wondering how access control lists are being used that block these ranges from going across their routers, unless, I'll be upfront with you, there are some ISPs that use private addresses even in their core and don't NAT till you get to the edge of their network. Okay. So, but most of them block these private addresses from getting anywhere into their network. So you don't have to worry about bleed over of these addresses into anywhere else. NAT translations can be one-to-one, one-to-many, but its primary function is this. You've got a border router that is a NAT-enabled border router, and you'll get a public address or a set of addresses on the outside interface. The inside will use all public, excuse me, God, I keep saying that, all private addresses. Okay. So here it has 10.110/30 for the serial link between R1 and R2, and then two different 192.168 numbers. Both of those are RFC 1918 addresses. There's only one exit point to the internet, so we NAT it right here on R2, and to the outside world, it gets translated to some public address. Now, NAT, here's an example showing you a picture. Goes up 192.168.10.10, goes to the router, gets NATed to an inside global. Okay. Now, Cisco come up with this inside local, inside global, outside local, outside global. The whole reason these exist is because there were times, and there are times, when two networks are joined together, and those two networks both use the same private address space. And so there had to be a way to keep up with both the inside and outside in case translations were going both ways. We do not typically translate both ways on most networks. So 99% of the networks, inside local is your private inside address. Inside global is the global public address that the private address is NATed to. outside local and outside global is just the destination public address. Okay, so outside. For most of us, we can pretty much ignore this local global thing and just go with inside outside. So the inside address is 192.168.10.10. The outside address we're trying to get to is 209.165.201.1, and we are being NATed to 209.165.200.226. So to the outside world, 192.168.10.10 appears to be this 209.200.226 number. Goes to the web server or whatever, FTP server, whatever it happens to be, comes back to the destination 226, it looks in the chart, says, oh, that's 192.168.10.10, sends it back in. So no big issue there. So with this, we see again, the inside address is the address of the device which is being NATed. Okay. The outside is the destination. The local address is an address that appears on the inside portion of the network. Okay. So anywhere on the inside, it appears. So local address, the outside local will still be that public address you're going to. And the global address are the addresses as they appear on the outside of the network. So here's an example. Source address 1010, outside local is 209.165.201. Outside local doesn't change, inside local doesn't change. What changes is the inside global, because that global is what the world sees. So just think of everything on the left, one way you think about it, is local. Anything on the right, global. And actually, most of the diagrams that holds true. It's not going to be true on networks, but that's just one way you could kind of look at it. Here's our NAT table. Inside global is 226. Inside local is 1010. Outside is this 201.1. Okay. More than likely on this ISP, by the way, right here, are access control lists that block RFC 1918 addresses. So they can't spill out into the ISP. Now let's talk about types of NAT. There are the easiest. Let's start with the easiest, static NAT. We need static NAT. Okay. When you think about static NAT, what are some things that have to have a public IP address for you to be able to get to them? Give me an example, anything.
Well, if you're printing to a printer that's not sitting on your local network.
Yeah, but that's
right?
not something we usually do a NAT to.
Oh, okay.
So that would be, you'd be printing over the internet to a public address.
Okay.
But what do we go to all the time across the internet? So if I go up here and go to
Cloud.
www.cheese.com, where did I just go? By the way, this is where I always go to check internet activity. Cheese.com. I went to a website, right?
Yeah.
So you got any web servers are going to have some type of public IP.
True.
If they're accessible on to the outside network. So cheese.com has to have an IP address somewhere. How about email servers? Most of the time we're going to have one for those. So in our networks, we've got to have some devices that have a static one-to-one NAT. If we wanted the SSH from the outside to a server on the inside, you would have to have a public address you could SSH to. Now, by the way, I would never, ever, ever have someone do this on their network, because they're punching a hole into their inside network. I wish when they did a static NAT like this, they would show it hanging off of a DMZ off of the R2 or off of a firewall somewhere. You should not punch a hole into your server like this to get to a server, but be what it may. And so static NAT is literally a one-to-one private to public. Okay, that's exactly what it is. That's what we set up. So in this case, we've created a NAT on R2 that says that 209.165.200.226 now goes to the server 10.10. And we put that into the table. We've also set up 227 and 228 to be 1011 and 1012. Now, hopefully, we've done some access control lists on R2 and are not just allowing all the internet traffic to come into these machines. But if you didn't do some type of ACLs, any machine that knew 226, 227, 228 could get into any services that are running on 192.168. And by the way, there should be a .10 right there on all these. They've got a mistake. Static NAT 1-to-1. Very, very good for web servers. Any device has to be connected to over the internet. Has to have a public IP address. What's a negative of static NAT? There's several, but what do you think one negative is?
Well, if you change it for any reason, then all these other devices have the wrong IP address, or
Right.
if you
So
changed
you'll have
it.
to change, and if you've got a DNS mapping to it or whatever, you have to change those. Plus, it's really not saving us anything in terms of IP addresses, is it? Because in a static 1-to-1 NAT, every private has to have a public IP. So there's no real bang. We're not saving anything when we do static NAT. Okay. Now we do also have a thing called dynamic NAT. Now I do this two different ways, and I don't agree with I wrote a book on CCNA, and this is how I describe it in my book. There's dynamic NAT, okay, which is NAT to a pool of addresses. And the way this works is you create a pool and you hand out those addresses until the pool runs out. And with that, that's called dynamic NAT. And if you run out of addresses, nobody gets out until an address is released and is available back in the pool. Then there's another thing I call dynamic NAT with overload. Okay, that's NAT to a pool of addresses until the final IP. Then you pat on that final IP. Okay. So an example here, if we did dynamic NAT with overload, would say actually call pat with a pool, but if we did dynamic NAT with overload, we would create a pool from 226 to 230. 226, 227, 228, 229 would all be handed out 1-to-1 with inside host. And then everyone else in our inside network would share 230. Now, the rule is one public address can handle about 4 million internal sessions. Now, it's not 4 million clients, that's sessions. So imagine my machine right now probably has 14 or 15 sessions connected to the internet. Different port numbers, different, the IP address will be the same, but different port numbers internally going to different resources on the internet. So 4 million sessions to one public address. Now, the book or this just calls that port address translation. They do it, they just say, okay, we're going to do now here's something really interesting. Notice how 1010 is going out to 1:80 and 1011, 1331 is going out to 129.80. And so it's going to go out to the server. It's going to get natted, and they're going to get natted to 226. And you'll see how it keeps up with the address. Okay. Keeps up with both the inside address and the actual port. And then it sends it out. And then that way, when it comes back in, you can see how it's created a table now. And so in this case, this is true PAT. It's sharing one IP address, and that also happens to be the same IP address as the outside IP on the router. And that is being used to do port address translation. This is how our home networks work so that we can get out to the internet. We're all able to do it just like that so we can get out. And this can happen, if a host or a inside host happen to pull the same random inside port. By the way, every time you connect to a resource, you create a source port that's a random port. So two machines could possibly pick the same internal port. Okay, 1444, and it gets mapped to outside of 226, 1444. Well, PC2 also goes out and picks 1444. Well, all it does is increments in the table to 1445. Okay, and says that maps to 1444 and then sends it out. So that way, when it comes back in to 1445, 226, it knows to send that in to 12, 1444. So it's okay if you have a overlap in source ports. You'll just increment it on the NAT device itself. So a NAT-PAT comparison, NAT is a one-to-one mapping. That's what they say. Now, again, I say static NAT is a one-to-one mapping beside inside local. Only uses IPv4 addresses in the translation process, and there's a unique global for each inside host. And that is if you're using static NAT or dynamic NAT without overload. If you're doing PAT, then there's one global address mapped to many inside local addresses. It keeps up with TCP, UDP, and ports, and you can share it with many inside hosts. Okay. So again, here it is, one-to-one mapping. PAT is a one-to-many mapping. Questions? Let's look at some advantages. First off, the advantage is we can continue to use IPv4. Without this, we would be out of IPv4 addresses, and we would all be running IPv6 as our primary transport protocol or something different. Okay. So it conserves public addresses or conserved public addresses. It does increase flexibility because honestly, you got to think about it. Once this is set up and you've got your inside private addressing scheme, you can change ISPs and change all your NAT information. Now, that is a major thing. I won't say that's easy, but you can change and fairly easily change your NAT information. It's not as super easy for static one-to-one mappings because typically those one-to-one mappings have DNS associated with them also, and DNS causes all kind of issues in terms of updating DNS on the World Wide Web and across the internet. So the negative is that we don't have full end-to-end connectivity. So in other words, although I can tell that a communication came from Stanley Community College, and I can track it all the way back to our NAT device, unless the device is actively going through the NAT device at that moment, I may not be able to find exactly what machine was connected using that port and IP address. So that is the negative. Okay. Some people think that it's also a benefit though, because it hides your internal network to the outside world. So that's neither here nor there. Some people say it's an advantage. Some people say it's a disadvantage. I pretty much go with, hey, guess what? Without it, we wouldn't have the internet we have today. So we're kind of like we don't have a whole lot of choice. Now, here's where it gets into trouble. There are some places in India where traffic is being natted between 5 and 7 times before it ever is actually natted to a public address. So think about that. There's 5 to 7 different levels of private addressing. And so tracking back to an individual in that instance is nearly impossible. Okay. The other thing is this. Notice when we watch this video here, or watch the videos earlier, notice how it was being translated. What happens to traffic when it's being translated like that, folks? I mean, even this next available port, what happens? Think about, what does this add into your network? What is added anytime you go through any network device? What'd you say, Suzanne?
Overhead.
Overhead and delay.
Uh-huh.
You know, anytime you go through a device, so it's not only that it's going through a device, but it's being translated. So you have to be careful because it does add delay into it. Now, having said that, it's pretty minimal delay for what we do now. So let's look at static NAT. Here we have a web server. Again, I wish they would put it on the DMZ, not on the inside network, but it is what it is. And we're going to try to do a static NAT creation for this web server 254 to be 201.5. Okay. So we just go in and configure static NAT. So I kind of make it a little sing-song. IPNAT inside source static, inside outside. So IPNAT inside source static. Now creating NAT, especially static NAT, is a 2-step process. One, set the NAT. 2, set the inside and outside interfaces. Okay. So it's not enough just to do this. If you do this, that's all hunky-dory, but nothing happens until you set inside and outside interfaces. So IPNet, inside source static, inside outside. So this is the IP of that's your private, and there's your public address. Then you go to the interfaces and you set your outside and inside interfaces. 99.99% of the time, your inside interface will be the private address and the public side will be your outside. And I say 99.9 because there is that 0.101 or 0.1% where you're natting between both ways. You nat both ways. You still got an inside outside, but it gets a little weird then. How do you see NAT? Well, show IP NAT trans will do it for you. This is very simple here. You see this 10.254 is going out. It gets natted to 201.5. Here, the client actually went to HTTP 209.165.201.5. It comes to the router. The router will convert it to 10.254, send it into the web server, and then the web server will respond, and it's reconverted to 201.5 on the outside. So right here it is. Inside local is 254. Outside global is, inside global is 201.5. And then the outside local and outside global address is that 254 that is the client. So verifying static NAT is super easy. Show IP NAT trans, and you'll see an inside outside. Inside global and inside local. So this is, you'll see the private address and what public address is being translated to. You also notice there are no port numbers being shown here. So that also is another thing to show you that this is a one-to-one translation. Show IP NAT trans if you want to see multiples. Okay, here's when there's an actual connection going on. This is when there's nothing going on between the inside host and outside. Here's showing you there's a connection between 201.5 and 200.254. Okay, so there's an actual TCP connection here. No port numbers, though. There are no port numbers. And there are two translations. There's the static NAT and the static NAT being used for that actual communication. Show IP NAT statistics will show you the interfaces that are inside and outside. And if you ever need to clear your NAT, you can do clear IP NAT trans space star, and that will clear out your translations. Of course, if you have a static translation, it will automatically be put right back in. That really only clears your dynamic translations. Questions? Anybody set up static NAT before? Anybody done it?
I have not.
It's very simple. I mean, it really is. It's not hard to do it all. You got a packet tracer on it, and it's very easy. Let's look at dynamic NAT. So this is what we're going to call dynamic NAT without overload. Okay. So you'll see it's a one-to-one translation to a pool of addresses. So to do this, here's what we do. First off, step one, we define a pool. Okay, so let's define our pool of addresses. IP NAT pool. Now notice we used all caps here. Whatever you name it here is going to be important because you're going to need that later. Start address, end address of the pool, net mask, and the mask that is used. All right. Step two, create an access list to define what can be natted or what should be natted. I told you, ACLs are used for everything. This says anything that begins with 192.168.0.0, it can be natted. Well, actually, this is just permitting 192.168.0.0. This tells it to be natted. IP NAT inside source list 1, so referencing this right here, whatever we made that, NAT pool. And notice we had to use exactly how it was created and spelled in step 1. So this says anything that matches list 1, NAT it to the pool, NAT pool 1. Now, what do we have left to do to make this work?
Put it on an interface.
Yeah.
Set your interfaces inside, outside. So set inside and outside interfaces. And then, lo and behold, you will NAT between those inside and outside using that pool of addresses. Now, the way this is set up, because of the way it was set up, you notice there's no overload at the end. Once it gets to 240, no other host will be able to go out until there's actually a NAT translation released. So if this is not enough in this range to cover every internal host, you can end up with hosts not being able to get out. You fix that by literally just putting the command overload at the end of this statement. And then it becomes dynamic NAT with overload, or really dynamic NAT with PAT. So here we look at the example here. You'll notice how .10 gets translated 226, .10.10 gets 226, 11.10 gets 227, and it would go on and so on and so forth down to 240. But at the end of 240, nobody else would get out. That would be the end. And this is just showing how it's coming back into 226, 227, and it's being translated. So verified dynamic NAT, show IP NAT trans. And you'll see here, it's a one-to-one mapping. See that? If you do verbose, it gives you a lot more information about it. It gives you when it was created, how long it's been used, all those different little things there. I don't rarely, if ever, use the verbose command. I've almost always just used show IP NAT trans. Clear IP NAT trans will clear your NAT translations. If you do a star, it clears everything out. Okay. So clear IP NAT trans star, or you can do a particular IP address if you want to. Show IP NAT statistics will show you if you have a pool. So this shows your pool name, net mask, shows your reference count, the start and end, and how many addresses you have, and tells you how many you've got allocated also. So it's pretty useful there. You can also look in the running config and do include NAT to see those. The one thing it doesn't show you, though, is it doesn't show you whether or not inside or outside's been set. PAT is port address translation. So now what we're going to do is keep up with both the inside and outside addresses and the ports. So protocol and port are now going to be looked at so that we can get all this information together. Here we've seen we incremented 1444 so that 11.10 could get out. There's two ways that they talk about doing PAT. One is to a single IP address. This is very common for branch offices and like home offices. IPNAT inside source list 10011 overload. And then you got your access list permitting everything in the 192.168. So this says anything that matches access list 1, have it share the IP address that's on 0011 and use PAT. Inside, outside. Now, the reason I call this PAT is because this is truly port address translation. We are translating to the port address of 0011. Now, they call this PAT with an address pool. I don't call this PAT. I call this dynamic NAT with overload because, look, you've got your pool that you created. This is pool 2, going 226 to 240. And by the way, you could not have this pool and the other pool on the same router because they're overlapping. It would give you an error message when you tried to create this. It's either NAT pool 1 or NAT pool 2. You couldn't use both. Access list 1, and then it says IPNAT inside source list 1, NAT pool 2 overload. This makes it do a one-to-one mapping for everything up to 240. And on 240, it will start doing PAT. It'll do port addressing. Okay. And then do inside, outside. So here's a example. Source address of 1010, source port 1444, going out to a web server. You'll see that it gets NATed to 225, 1444, going out to the web server port 80, and it comes right back in. And then the internal host 10.11 got NATed to 200.225, 1445, going to the exact different web server, port 80. Okay, and that's just the two different PAT mappings that are in the NAT table for the router. It's very simple. It's very easy to do, but it's extremely important in our networks. Now, when I'm troubleshooting NAT and PAT, there's a couple things I always check. If I'm just doing regular PAT, so true port address translation to a port, the very first thing I always check is my NAT ACL. Did I do my access list right? Did I put in the correct thing? Did I fat finger it? Okay. If that is working, then the next thing I usually check is just my actual inside outside. Did I remember to do that? Because it's very common that I don't remember to do that. I'll get in a hurry, I'll make the ACL, I'll do it to a port, tell it to overload, and then forget to set inside outside. Or I'll flip it. I'll accidentally put inside outside or outside inside. Now, looking at verifying PAT, so show IP NAT trans, you'll see the protocol plus the port numbers. That's how you can tell the difference. If they show you IP NAT trans and say, what are you seeing here? If you're seeing the protocol and port numbers, then you're doing PAT. And for the purposes of the curriculum and the test, just realize it's PAT, even though if it's dynamic NAT with overload, they call that PAT. I had an argument with when I did write the book about that with my co-author and had to explain what I was talking about. And once I did, they were like, oh, yeah, that makes sense. Now, last but not least is NAT 6-4. So what if we have a network where there's both IPv4 and IPv6, but we're not going to do dual protocols on everything? What we can end up doing is having a router that can convert from IPv6 to IPv4 and vice versa. This allows you to have both IPv6 only networks and IPv4 networks on a router and have them communicate with each other. They mention this and then immediately say this is beyond the scope of the class. So I love how this says NAT for IPv6 should not be used as a long-term strategy, but as a temporary mechanism while converting. Well, to me, it's just as easy to be dual homed as it is to do NAT PT. So NAT PT used to be there, but it's actually been depreciated. NAT 6-4 is now its replacement. But even then, they're like, this should only be used until you either convert fully to IPv6 or become dual home, one of the two. Okay. Questions? Questions about NAT? Anything in NAT that gives you causes issues for you?
Nope.
All right. Well, let's go and look. I'm going to just hit the WAN concepts real quickly because they're this is a pretty simple little chapter here. One thing I always get tickled about, folks, is when we talk about WANs and we talk about high-speed internet. When we talk about high-speed internet, how fast is your internet at your house? Mine is between 100 and 200 megabits per second. And I got Starlink.
We got fiber optics at my house.
Okay, so you got a gig then.
Mm-hmm.
All right, anybody else got a gig? What else you got? What speeds we got going on here?
I'm right around that too, right around a gig as well.
Okay, so you got another gig fiber?
Yeah, I have fiber too.
Okay. So answer this question for me. What's the slowest NIC you can buy on a LAN?
My old one with 5 megs a second.
Yeah, I mean, but can you even buy that now?
No.
No. You would be hard pressed to find a fast Ethernet NIC right now.
Yeah, because the minimum or copper cable standards is Cat 6A almost. So you're looking at one, 1 meg.
Gigabit, right.
Yeah,
so
gig.
Our lowest speed that we typically find on a LAN is our fastest speed we find on most high-speed internet connections. Now, are there faster connections on the internet? Yes, by far. SONET, there's other things that are much faster. There's fiber going across, dark fiber, those types of things. Yes, they're much faster. But it's always interesting when we talk about high-speed internet and WAN connections. Really, WAN connections are not all that fast historically. WAN connections do typically deal with layer 2 protocols. So HDLC, frame relay, Ethernet, ATM, PPP, all of those are protocols that are WAN-based or WAN protocols. We have in our WANs, the big difference between a LAN and a WAN, LAN's a limited geographical area, WAN is wide area. Typically, LANs are organized by a single and owned by a single organization, whereas WANs may be owned by multiple organizations or be multiple LANs connected together. Typically, I say that LANs are faster high bandwidth speeds. WANs provide low to high depending upon what you pay and what you've got available in your area. Right now I have Starlink because that's the fastest I can get. It's either that or 20 megabits DSL. If I could get fiber, I'd pull fiber to the house, but I live out here with cows, so that's never going to happen. Private and public WANs. There are, you can build your own WAN, but man, it costs a lot of money. But there are groups that have done that. Teaching class this morning, the government can build their own WAN. They do that to guarantee security mainly and to guarantee bandwidth, but it's mainly to guarantee security. That's why you would have a private WAN versus a public WAN. Here's our WAN topologies. It used to be, we used a lot of point-to-point. In other words, literally serial links from A to B. We don't really do that much anymore. We don't use serial links anyway. We do use point-to-point, but this is typically now some type of dark fiber or just an Ethernet connection, Metro Ethernet that we purchase. So we can just get a piece of fiber from site A to site B. The beauty of it is, especially if it's a piece of fiber, you can put 100 gig link on or 100 gig Ethernet on both sides or 400 gig Ethernet on both sides, and away you go. And it's awesome. But that used to be one of the ways we actually had some fairly slow speed topologies on our WANs. Hub and spoke is another one. Okay, so here you've got a hub with spokes. This is something that was very familiar, very similar to, or very much used with frame relay. You'd have a single hub and then spokes off of that hub connected with frame relay. We've got dual homed, and this is where you've got multiple connections. Okay, so you got these multiple hubs and each spoke is connected to multiple hubs. That's for redundancy. Fully meshed. Okay. This allows for full redundancy and it gives you your best fault tolerance because you're fully redundant. And then many times we go with something like this just because we can't afford the full redundancy, or we decided that maybe site D is not, if it goes offline. What I would probably do if this was me and I would have been designing this network, I would have at least took site D to site C or site B to give me, if you did that, then everybody would actually be fully redundant without having to have that final between C and D, or almost fully redundant. Why doesn't everybody just make everything fully redundant? Money, folks. It's all about money. It's about money and availability.
Yeah, too expensive.
It's expensive, and you may not have the availability of a site. You may not literally be able to get a connection from site D to site B. Now, I will say this entire section doesn't cover low Earth orbit. Love or hate Starlink. Starlink is changing the ballgame when it comes to internet connections. You've got places in the world that had zero internet connectivity who have very high speed, or compared to what they had before, have high speed internet. Taking into account, you've got something that's literally the size of a book that you can carry around with you in a car and have a generator, and you can be on the internet anywhere. It was a massive godsend up in the North Carolina mountains when Starlink was brought in for folks, because they had zero way to communicate with anybody until that was brought in. So it's going to have a really big place in disaster recovery as we move forward, all low Earth satellites. Now, carrier connections, single WAN. All right, this is a single WAN connection. This is a dual carrier. Now, one thing I want to warn you about, if you're like us, you may have, let's say, ISP1 is Verizon, ISP2 is Sprint, or whatever. Make sure that these two are not, if this is Bubba's ISP1 and Mary's ISP2, make sure Bubba and Mary aren't both connected to Sprint on the upside. Because if you go to the right of these and they're both connected to the same ISP as their upstream ISP, you are paying for redundancy that's not really redundancy. Okay? Because if the upstream carrier goes down, and let's say Bubba's and Mary are both going to Alltel, or Alltel's not around, Sprint goes down, you lost everything. So you need to do your due diligence and look above the ISP 1 and 2 and see what's above them and what they're using.
Right, because they could tell you, when I worked for SBC, if you wanted, redundant links, then there's a price for that. How redundant do you want it?
Yes.
And they would charge you accordingly. So you
Yeah.
could go all the way to the main core, or you could just be out of your city, whatever you wanted to pay for, because a lot of times some of those cables were running in the same manhole.
Yeah.
So you had to tell them, no, it needs to go out of this and go south. This one needs to come out of here and go north,
Yep.
and not be in the same manhole that's going to get hit by the backhoe digger.
The same
and
backhoe
take
will
some
cut
run.
both cables. Exactly.
Yep.
And
Mhm.
that's something people don't think about, and they don't even map it out. But you really, if you want true redundancy, you've got to get down to the level of looking at where the cables go. To the point of, how many of you have seen, I love this map. Let me see if I can see it. There it is, under. This map right here is phenomenal. How many of you have seen this map? This is the map of the world.
Yeah, the underlying cables. Yeah, I've seen.
This
That's
is
pretty
a
cool.
submarine
Yeah.
map. This thing is intriguing. I love showing this to my students. These are all the cables going around the world that are the underground cables. Now, here's one thing we found out back at 2000, September 11. Most of the cables to the United States came in right here.
Yep.
Okay. And as soon as September 11th happened, guess what? They really quickly started moving some stuff up and down. You see right here, there's one coming into right around, I think that's Norfolk, Virginia Beach. That's Virginia Beach. So that comes in at Virginia Beach. We've got them down here at Myrtle Beach.
Yeah.
And then another big hub right after September 11th, they brought them into Jacksonville, right in here to Jacksonville, Florida. Okay. But notice this is just, to me, so interesting.
Well, even
All,
in the United States, traffic across our country,
right.
the control traffic travels a different path than the data. And you would be very surprised about where the control traffic goes to, like what little cities across Missouri, as an example, are very important, and people don't realize it because there's not maybe 1,800 people in that town,
Yep.
but the core comes through there,
And they did that
and
on
so
purpose.
yes, and so if someone wanted to do damage to somebody, it's only all you really need to know is where are these little core places, and they're out in the middle of podunk nowhere, but
Yep.
nobody knows that. And so
Yep.
the traffic flows separate, and all you got to do is take out the control line. I don't have to take the traffic line out. I just
Yep.
have to take the control line out.
I'm
And so it's
amazed
just
by this
interesting.
right here. There's a
Mm-hmm.
this one that goes from here to here, Freeport, Texas, over to here. It's neat. It's neat how, and then you'll see something like this. Look at this. You'll see a little cable run out here to an island in the middle of nowhere.
Mm-hmm.
French
Well,
Polynesia.
in my Big C studies, they always tell you that it's really true. Over 85% of your failure in a network is at the physical layer. So even as simple as somebody moving the wrong cable when they did a cross patch or something, it's
Yep.
considered physical. So you can see how easy it could happen here. You know,
This
some of them coming in the same place.
and this blew my mind right here. Okay, so here's I messed up. Here's the Suez Canal, right? So right up through here's the Suez Canal. Look at all these cables. What goes through here all the time? Tons and tons of shipping, right? I mean, no wonder somebody drops an anchor and tears up a cable every once in a while. Because look at all of this going through, right up through the canal. I mean, it literally goes through the canal. Or it hops across, right here. This is actually all, looks like it's underground going over to Alexandria and then hops across the Mediterranean. But it's still pretty phenomenal that you've got that amount of cable in that canal. So, but yeah, this is neat. If you I never showed this to your students, show it to them because it's worth kind of showing. Look at all these little islands right here, all the little spots. I did. Hold on, I did my. Accidentally, let me refresh it. Hit my. Oh, I've done my. There we go. My view's bad. I gotta change my view on my. There we go. So it's pretty neat. And you can even look, it's got a mark here. So if you want to find one, you can actually find them and see them. But that's a cool map. And notice there's absolutely nothing going to Antarctica. So I like that one. That's a cool little thing to show students. All right. Evolving networks, again, small networks, broadband, using some type of broadband access to the internet. I will say this, 3 years ago, last time I went to Cisco Live, which I am going again this year. Woohoo, thank goodness. Had just started talking about low Earth orbit satellites and the effect it was having on mining facilities. Because one of the things, these mines are out in the middle of nowhere. Well, they had people at the mines were going out and buying their own Starlink and installing it on the mine site, and nobody knew it was even there, and suddenly had internet access out there. Well, guess what that opens up? It opens up to all those IoT devices on the mine to be an attack. And so they had to start very quickly creating new policies for that. Here's a campus network with a firewall, branch network, and then we, of course, got our distributed networks, which are across the world. Now, WAN standards are almost all in the layer 1, layer 2. So they're TIA, EIA, or IEEE or ISO standards. So they're physical layer or data link standards. Some of our layer 1 protocols that we talk about are SONET, SDH, DVM, DWDM, dense wave division multiplexing. Layer 2 is broadband, DSL cable. Some wireless standards. The MPLS, which is basically, if you've never heard of MPLS, it's basically like VLANs for ISPs and the ability to keep traffic apart from one another inside their cores. PPP, which is not used much anymore. HDLC, which is used even less than PPP. And then frame relay and ATM, which are both legacy modes. I think you'd be hard pressed to find anything running ATM anymore, or frame relay for that matter. So here's something we do need to memorize, and we'll go over this and then we'll call it a day. But there is a point where the phone company or the provider's equipment ends and the customer's equipment begins, and that is called the demarcation point. All right. The demarc is different depending upon whether you're in Europe or in the United States. But it used to be, especially back when we had lease lines and those types of things, we would have on the customer premise equipment a thing called a DCE. Now, DCEs, DCE, oh, that's not it. All right, DCE, data, here, data circuit terminating circuit.
You had DCEs and DTEs.
Yeah.
And they used to actually be physically separate cards in the
Yeah.
routers.
Yeah. Let me see if I can CSU. Let me find a CSU DSU image. That's what I'm trying to find. CSU DSU.
We used to have those. They were in the central office. They'd all be rack mounted.
Oh yeah, and they were
cards
heinous
you'd slip
because
in and out. Mm-hmm.
here's how we used to do it back in the old day. Back in the old days, you'd have this box sitting on beside your router. There'd be a RJ45 coming in. That's the telco demarc. Your CSU DSU. This would provide all the timing and all of the clocking for your incoming lease line. You'd have a V35 cable that would come over here to your router to a WIC, which had a serial on it, and then that would come into your internet or into your network, and you'd have your 10100 internal port here. So this was how it was set up, and that was your demarc. Now, there were also a thing called TSU. Now, this TSU was basically the same concept as CSU DSU, but it was a terminal service unit that was actually inside of, you slid it into a WIC slot. It did the same thing. It provided clocking. Luckily, we don't do that anymore. Here's a channel service unit that's showing you the back and shows you the V35 interface right here. Okay. So this was a V35 cable that you'd plug in and you'd have to screw it on and it would provide it. The problem with this is you had to find somewhere to put this thing. You had to provide power to it. And it had a nasty habit of anytime there was lightning or something come in, it would get killed. Okay. So CSU, DSUs are not something we use anymore. We still do have a demarc point though. So there's some place where the local loop stops and the customer premise equipment begins. That typically now is either your DSL modem, your broadband modem, or it's where that cable from the ISP comes into your broadband modem. But DCE, data circuit terminating equipment, provided clocking. DTE, data terminal equipment, did not provide clocking. And you remember that by DC and DTE. All right. So all of these are different types of devices that could be in the network or on the network. We typically don't deal with these as much. We still do have this local loop, especially if you're going to like DSL or cable modem. You definitely have that because you're connected either to a DSLAM or to some type of DSL aggregator that's above you. But many times now, what we actually have in this local loop is just an Ethernet connection into the network via fiber or something else, which is very nice, where we have Metro Ethernet. So here again is another good picture of some DCE, DTE devices. So voice band modems, DSL modems, cable modems, those are all DSC devices. And then you connect that to your internal router. And then that's, you know, some people, it depends on who you talk to, say that the demarc point can be where this cable comes in from the WAN, or it could, some people say it's in between the DTE and DCE. What we typically say is who owns it.
That's what I was going to say is if it's owned by your ISP, it's on the far side of that.
Yep.
And if it's owned by you, it's on the other side.
Exactly. So whoever owns it is typically, so if you don't own your modem, your cable modem, then that's the demarc point. They own it. That's them. If you do own it, then you're probably, it's yours. It's considered the demarcs on the other side. Okay. Now here you probably, now this, I got a question for y'all because I don't have fiber at my house. Do you have the fiber coming into an optical converter that then converts it to an RJ45 for you? Or does it just come in fiber to a router and then that router is just like a regular home router?
Mine's the router to the home router.
Okay.
Let me look at mine.
Yeah, I have a box that they attach to my room back here.
Okay. So let's see. So something like that.
No, it's a. I wish I can get a picture of it. Hold on, maybe I can get a picture
That
of
might
it.
be. That's the transceiver there.
I actually have a fiber coming into mine. So they have a box on the wall that their
Okay.
cable comes to, and then it feeds off of that into the router that they provided.
Okay. And so there's actually a fiber cable cabinet in your house.
Yeah.
Okay.
And I live out on a 40-acre farm out in the country in the middle of nowhere.
Oh my goodness. I'm amazed you were able to get it. So there's the cable that comes all the way in and there's it just goes into the house. That's neat.
Yeah, I tried showing it, but it's sitting off the back here. I can't.
Yeah. That's okay. That's all right.
Yeah, because the guy told me when he came and installed it, there's a very thin fiber wire that connects to the outside. He says, "Oh, don't move that." Yeah, cause sort of something like that.
Something like that. Okay. Yeah, and and then that connects to inside to the house to the router itself.
Right.
Yep.
Okay.
Yep.
That's neat.
When Google was out putting fiber optics in Kansas City to the home, that's the box they use, something like that. They had their PEDs here and there, you know, and then they ran everybody's place. They ran the fiber up to the house, mounted the box, and then if you wanted to connect to them, you know, they were happy-go-lucky. Yeah, if they didn't want to, then they were ready for the next person.
Gotcha. Yeah, and that I wish that was actually my hope that they would someday eventually get fiber come out our way, but it just never happened. So,
well, some of it's being done in rural America for governmental grants, so you might look to see if they're just not capitalizing on it. But they brought the fiber up to the east corner, southwest corner. We live on the northwest corner, and they said, "Well, we don't have any more money." I said, "I'll dig the hole myself."
yeah.
And they said no. And so I said, well, let me tell you, you ran that for 2 miles from the highway. There's nothing but a bunch of farmers between here and there, and they don't use it. But
Yeah.
I will.
Yeah.
You won't even be able to sell it to them because they'll say, no, my TV's working fine.
Yeah. I did.
There's like
I actually,
another question
go
that
ahead.
kind of spurs from that. I was thinking, when you said farming, I thought of it here. I
Mhm.
mean, Maryland, we're not really like, we're old people out here.
Right.
But they were talking about transition to like automated, internet connected tractors, farming, like mass farming. I mean, that would require connections too. So it was just,
Well,
is
most of
that something
that's
that you guys have heard of? I've
mo-
never, I mean, out
most of
here it's
it's
different.
cellular.
Okay,
They,
cellular. Okay.
a lot of that's cellular. That they connect up their GPS to all the uh, equipment that they're out there
Okay.
with. It's mostly GPS.
And I
Gotcha.
do think low Earth orbit satellite's going to help with that too. When you
Sure.
think about a tractor, you can literally put on a tractor a Starlink remote or mobile unit
Yeah.
and run it off the alternator on the tractor, and you could
Yep.
have full internet access all day
Well,
long.
my nephew goes out and he works for John Deere, and he goes out and he maps
Yep.
the GPS coordinates of these farmers' fields. And so most of Kansas is green, and so
Yeah.
they use John Deere, and over here they're using HI. But
Yep.
they map all the coordinates on their fields, and those guys are just up there in the box in case they need something. But you see all these little kids on Facebook running stuff where, oh, those things are running already off of GPS, they're just sitting there in case they need them, tell them put on the brake.
Yeah.
But
And
that's how they're
there's a
running.
lot of, and there was a whole discussion about that too, because um, you think about the amount of data that is coming in through those tractors, the amount of harvest
Yes.
data. You
Yeah.
think about I mean, I hate to say it, be kind of conspiracy theory, but if you're John Deere and you're pulling all this data on the grain harvest in Kansas, and you see it's going to be a terrible harvest, what do? You short grain. You know,
Mm-hmm.
there's a lot of questions about that data and how much
Mm-hmm.
it's going in. So it's going to be an interesting as we continue to move. My friend's a farmer, and out in Kansas you can do that. Around here, there's too much up and down in the fields. They have to really watch their stuff. They can run some of it in automated mode, but there's a lot they
Mm-hmm.
can't because of that.
You're just talking flat.
Yeah, if it's flat, you're good. You're good. Well, everyone, that's what I'm gonna call today. Are there any questions before I stop for the day? We will be back again next Tuesday. So it is Tuesday from now on. We're good for until in 2 weeks, 3 weeks. I go to a conference on Tuesday and come back on Monday, and so we'll miss that one day. Man, my hat's crooked. But
Do you happen to, if you could send us that date, that'd be good, so for scheduling purposes.
yeah, I will. I'll let you know. It's going to be. I can go ahead and tell you the exact. It's going to be the 25th, Tuesday 25th. We will not have class.
Okay.
So, and I'll actually go ahead and just delete that one so it'll come off of your schedule. It'll come off your uh, calendar if you had it on your calendar. But 25th, we will not have class. I'll be in Milwaukee. So, but we will meet the next week on the 1st. So. All right, everybody. Well, thank you so much. I appreciate it. And we will